Thanks for joining me today. My name is Kristen Torrance, and today we will be talking about evidence-centered design for virtual reality training. So I first learned about ECD while I was designing educational games for K-12. My background is in cognitive science and game-based learning. And when I made the jump to designing virtual reality training for adult learners, I really saw the parallels in immersive learning. And so currently I serve as the head of learning engineering for a company called Tailspin, where I design virtual reality training and help develop approaches for evaluating the efficacy of our learning solutions. So we'll be using Mentimeter today throughout this session. There will be a good amount of interactivity, so please do keep your phones handy. Or alternatively, if you have a device with you, you can go to menti.com and type in this code shown here to participate. And I do want to kick it off with a quick poll to practice using Menti. So how would you rate your familiarity with virtual reality? Go ahead, and if you need to scan the QR code again, here it is. I'll give you just a second. And then let's take a look. You can also go to menti.com up here, and the code is up here, 73580793. Looks like we have some responses already. I've used virtual reality before. I haven't tried VR, but am curious. Okay, I design VR experiences, awesome. Cool, but it sounds like we have more people than not who have tried virtual reality. That's great to hear. All right, so it seems like for those of you who haven't tried virtual reality yet but are curious, virtual reality is defined as an experience of feeling really fully immersed in a virtual computer-generated environment. And users in these environments typically interact with simulated scenes or objects that appear real in the physical sense. And virtual reality can be experienced in both a head-mounted display, such as what's pictured here. It's sort of situated on your head, or you could experience it in something like web VR. Which is like a browser-based virtual reality simulation. So what differentiates virtual reality from other modalities? And I would say that, really the 3D spatial affordances of VR promote a very visceral learning experience. So virtual reality promotes experiential learning and situated cognition because learners can really learn by doing in authentic contexts. And research suggests that these three pillars, interactivity, presence, and immersion, are what catalyze this effect. So interactivity is defined as the degree to which users feel that they can influence the things around them. Presence is the feeling of being in one environment even if you're in another. And then immersion is the feeling of being totally absorbed in the things happening in your environment. And then there's flow, and there's some conflicting opinions in the literature. So some researchers treat immersion and flow interchangeably, while others consider them related but distinct. And what I believe makes evidence-centered design such a powerful framework for virtual reality assessment is that it allows you to assess learning without disrupting flow. So if you're unfamiliar with the term flow, it's basically a state in which you're so completely absorbed or engaged in an activity that all else is ignored. And when we design for virtual reality training, one of our goals really is to get learners into this optimal state of mind as quickly as possible. And it's achieved when we can strike a sweet balance between challenge level and skill level. So you can imagine that once a learner reaches a flow state, the last thing we want to do is pull them out of that state, especially for assessment and evaluation. And so thankfully, there's been a lot of research done in the video game industry on game-based learning. And now we're able to transfer those learnings into virtual reality training experiences. And this is where evidence-centered design comes in. And the key thing that really sold me on this framework was, again, that it allows you to assess learning without disrupting flow. So has anyone here played Portal 2? If you have, please go ahead and let me know in the chat. Doesn't look like we have any participants, at least virtually, who have played Portal 2, and that's okay. Portal 2 is a game full of puzzles, and really the goal is for you to get to an exit door by teleporting using a portal gun. And really throughout the game, you're faced with complex problems and challenges. Now, because Portal 2 provides players with extensive practice figuring out solutions, researchers have used it to measure problem-solving skills in students. Has anyone played Plants vs. Zombies 2? If you have, let us know in the chat. Not virtually. Great. Well, Plants vs. Zombies 2, really fun. Definitely recommend it. But in this game, you have an army of plants, and you strategize so that your plant army defends you against these really funny zombies. And the challenge here comes from determining which plants to use and really where to place them to be able to defeat all the zombies and protect your home. And researchers measured students' problem-solving skills in a modified version of Plants vs. Zombies 2 using this framework. And in both examples, the researchers used the measurement methodology called stealth assessment, which was really pioneered by a researcher recently retired, I believe, but out of Florida State. Her name is Dr. Valerie Shute. Her research is amazing, and it's based on the evidence-centered design for assessment framework from Ms. Levy, adapted to game-based learning. And so what is evidence-centered design? So it turns out that evidence-centered design originally originated in adaptive testing by the Educational Testing Service, the creators of the GRE. And they really wanted a way to measure large abstract constructs using an array of test questions. And in doing so, developed this framework for design and assessment. And since its creation, ECD has been used in the development of the TOEFL, the PARCC, Smarter Balance, and a number of other popular assessments. And what it is a conceptual framework that can be used to support the design of valid assessments by allowing designers to align the claims they want to make about a learner to things that they do in the context of related tasks. So what I think is particularly cool about learning about ECD's origins is that it shows that the modalities and technologies can evolve, but the underlying mechanisms of measurement remain valid. And I think there's something to be said about that. So you may be asking, why do we even need evidence-centered design? Well, part of our role as learning designers and practitioners involves measuring learning and making claims about learners. Is this person a high or low performer? Or can we say with confidence that this person can apply specific knowledge to perform procedures correctly? Or does this person need additional training or supplemental resources to be successful on the job? And so it's important for these claims to be both reliable and accurate, and that means collecting empirical data to support these claims. So how about a thought experiment? So imagine you're designing a virtual reality soft skills training on, let's say, inclusive leadership for managers. And a stakeholder comes to you and says, efficacy is important. We need to know that we're hitting our KPIs. We need to assess managers' level of social inclusion. All right, so let's do it. Go ahead and scan that QR code and pull up Mentimeter again. If you don't have it up anymore, I will be able to share that link with you and the code, or feel free to scan this QR code, but share your ideas on how we might assess social inclusion. Choose your own adventure type cases where they need to select from different ways to respond to a situation. Ooh, I like that. Body language. Yeah, there's plenty of things we can do. We can administer a survey when learners complete a training, or we can send out a questionnaire to coworkers or interview their employees to see how socially inclusive they are. Maybe we can take a look at their 360 feedback, interviews, or performance reviews to, see code comments around social inclusion. And maybe we have some additional time. We can do some field observations or sit on a Zoom call or two. There's a number of ways that we may be able to assess social inclusion. But wait, there's more. So the stakeholder comes back to you and says, their time is precious. We don't want to bug them with post-training questionnaires, and our resources are limited, so we can't interview their employees or collect any new or analyze any existing data. Well, that makes it more difficult, right? So if the virtual reality training is the only medium that we can put in front of the managers, we will need an accurate way of measuring social inclusion as an output of taking the training. And this is where standard assessment strategies fall short, especially for virtual reality. So this brings us back to the evidence-centered design model. If we could weave in the assessment really into the foundation of the virtual reality tasks, then learning can be measured without breaking flow and immersion. So evidence-centered design, again, is a systematic method of designing assessments really focused on evidence of competencies as the basis of constructing VR learning tasks. So by approaching VR learning experiences with the end goal of assessment in mind, we're able to intentionally design tasks aligned with target competencies. So in other words, evidence-centered design allows us to make evidence-based claims. So by knowing what we want to measure, we can design activities that solicit learners' execution of those competencies, evaluate their performance, and then use their proficiency with the task to make inferences about their competency levels using statistical modeling. So wrong slide. Okay. So what does this mean for virtual reality? So it means that actions and decisions a learner makes in the virtual environment can be used as evidence to infer a level of proficiency in a competency. So for instance, vocalizing one of these response options on the right while engaging in a conversation with a virtual human is an example of evidence. So me selecting, hey Cameron, what's this about? Is an action that I make on the virtual reality system that is collected and can be used as evidence to infer competency. So evidence-centered design does this through the interactions of three primary models: the competency model, the evidence model, and the task model. And if you move from left to right, from the competency model to the task model, it's a design framework for how to design virtual reality experiences that are intentional, focused, and collect evidence of competencies. So by identifying what we want to measure in the competency model, how we're going to measure it in the evidence model, and where we get the data in the task model. But if you move from right to left, from the task model to the competency model, you can see that it's now a method of measuring competencies based off of the evidence collected using predictive modeling. So given the data collected in the task model, what can this evidence say about that performance? Excuse me, I had to cough. And then how does knowing this about their performance shape our inferences about learners' competency levels using the competency model? All right, so the competency model asks, what are we measuring? What do we want to be able to claim about a learner? And you can create a competency model by unpacking competencies from the unobservable facets to observable variables, ending with behaviors and actions that can be observed in the VR system. Now you can see here on the very left-hand side of the diagram, you begin with a competency, and then as you unpack and you move to the right, the competency facets get increasingly observable, ending with observable indicators on the right-hand side. And these are the behaviors that can be demonstrated in the VR experience. All right, so let's try it out. This is an example from one of Dr. Valerie Schute's papers. So let's say we want to make a claim about someone's overall tennis skill. Here's some of the variables that we may want to consider. So there's forehand, there's serve, stroke, overall skill, footwork, and backhand. So if you have given this array, how might you organize a competency model? So if you have a piece of paper handy, try sketching one out yourself using these 6 variables. And remember, the competency model starts with the most abstract or unobservable and then moves toward the most observable level. So think about what might be the most abstract variable here, and then think about what might be the most observable variable here and their relationships. And the models can go up and down, or they can go left or right, as long as the direction is consistent. So I'll give you a clue as to the shape of this competency model. And when you have a chance, go ahead and scan that QR code again. We're going to use Mentimeter.
Leading people how to do that job. I think it's been shown that quite frequently is not the case. Someone who does a really good job, does their job really, really well, doesn't always necessarily make it great. Sorry. So we bring them in and in what we call a safe and supportive environment. They get a lot of coaching, they get a lot of mentoring.
All right, so let's turn to Mentimeter again. Given this competency model structure, where do you think overall skill belongs? Looks like we got one response. Seems like most feel like overall skill should be at the very top. I'll give it maybe 15 more seconds for anyone else who wants to respond. Well, you are correct. That is exactly where overall skill belongs, at the very top. Now, How about this one? Where do you think stroke belongs? Okay, looks like we got 2 responses. And if you're familiar with tennis, this may come easier to you. That success in a game is broken into 3 competencies, and that each of those have their own competency models. For instance, creativity, conscientiousness, and qualitative physics. Now, the yellow boxes indicate actions or behaviors that are observed by the game system that then feed into the competency model. Now, here is a creativity competency model for that physics game. And you'll see that sometimes facets will have multiple observable indicators, such as the fluency and flexibility facets here, or sometimes they may only have one, like the problem-solving one here in this example. Now, do you notice anything else interesting about this competency model? It's that not every facet has an observable indicator. So every construct in cognitive skills has an observable indicator associated with it, but the entire disposition facet cannot be observed through players' actions in the game. So I wonder if this is a problem. So we can only collect evidence for cognitive skills. Is this an issue for us? Let me know in the chat if the chat is active at all. If you think that this is a limitation of the model. Or type in the chat if you think that dispositions are really just a construct that we'll need to measure outside of the system. So that was a trick question. So in a sense, we are able to infer dispositions using the cognitive skills observable indicators. And really that's the beauty of these competency models representing probabilistic relationships. So the inputs in the form of empirical evidence comes in the form of observable indicators here in the yellow, enabling us to infer the level of fluency, flexibility, and originality, and thus predict cognitive skills and creativity probabilities. And because of the relationships here, knowing the probability of cognitive skills is a certain level, we can then infer the probability of dispositions and its subconstructs to be at a certain level using Bayes' theorem. So calculating the value of dispositions given what we know to be true about the probability of cognitive skills. Now, of course, the more and more data the system collects just through learner interactions, the more robust these predictions become because there's more data to support these claims. Here's another example of a competency model in that same physics game. And they all sort of look very similar, right? Here's a third competency model of Newton's 3 laws. So those ones were for examples for a full success in a game. Now this one is for a competency model for a virtual reality HVAC training. And this particular one is for a specific service called a recovery service for HVAC virtual reality. And we created this model with the assistance of subject matter experts who are HVAC professionals and trainers. So success in an HVAC recovery service, you can see here, is comprised of equipment selection, equipment handling, and interpreting data. Now, we were able to further operationalize equipment handling into further facets. So manifold gauge operations, service hose connections, and tool operations. And then again, each of these constructs can be operationalized into actual behaviors that we can see learners exhibit in the virtual reality environment. Here's another example of one that we created. We're sort of building on our social inclusion thought experiment. This competency model was created by reading research articles focused on measuring social inclusion and social inclusion measurement tools. And you can see here that competency facets can include inverse relationships, such as the social isolation predicting social inclusion. And these inversions can be handled in the evidence model, which we will talk about next. So evidence model is a model for how evidence is evaluated and how the competency model probabilities should be updated given the evidence. So it's made up of the two models it's made up of are the statistical model and the evidence model. And the statistical model really is a model of the probabilistic relationships between competency model variables and observable variables. And so this includes their weights and how they influence one another, especially when evidence is collected. So the general premise for how the predictive model works is by calculating what's the value of competency facet A, given the evidence we have about indicator A. And then the evidence rules is a model for the identification and summary of evidence within the tasks, the virtual reality tasks. So this involves creating rubrics to measure the observable facets and classifying levels of performance. So it deals with scoring and categorizing whether the performance was high, low, or medium. And the evidence model, it really serves as a true bridge between the competency model and the task model. So we can think back to our tennis competency model example again to get back to basics. Remember that overall skill was further broken down into stroke, footwork, and serve, and forehand and backhand. Now, here is an example of the probability distribution of the variables. So starting from the top, the likelihood of someone having a high overall tennis skill is very low, right? 10%. A medium skill 30, and as you can see, it's much more likely that a person will have a low level of tennis skill. Now, this same general trend occurs at the second tier as well, but it's less severe, and the probability distributions get less and less severe at the third tier, where they're nearly equal. So how does this work? So given these original statistical probabilities, really, how does it work with the evidence model? So prior probabilities refers to the resulting probability once evidence is, posterior probabilities refers to the resulting probability once evidence is entered into the model. So it's really the revised or updated probability of an event occurring after taking into consideration this new information, which comes in the form of the learner's decisions in the VR experience. So again, this is updated using Bayes' theorem, which is really the probability of event A occurring given that event B has occurred. So for example, as you can see here in the gray, the probability of someone having a medium level stroke skill is 40, sorry, not in the gray, but for stroke, the probability of someone having a medium level stroke skill is 48%, given that we've seen them in the gray demonstrate a high forehand and a low backhand. So competency variables can also differ in weights. So let's say that a subject matter expert shared that the most important skill for tennis is footwork. Now, we can imagine that we observed each of these variables while watching someone play tennis. So we saw them demonstrate a high-level forehand, a high-level backhand, and then demonstrated a high level of serving skills. However, their footwork was low. So you can see here that although stroke and serve are both classified as high, the low footwork weighed more heavily on the overall score. So if all three variables were considered equal, we would expect that the overall skill rating to be medium to high range. But because footwork is so critical, the high and really the highest predictor of overall skill, this person's skill is predicted to fall in the low to medium range because their footwork weighted so heavily. So that was about the weights. So here's an example of a rubric that in that study they used to score, or that in the example they used to score the tennis observation. So their criteria included form, control, and power, and rated on a scale of 0 to 2. And you can see similar rubrics here when evaluating, or you can create similar rubrics, and you'll see an example of one that we created for the HVAC training when you're evaluating evidence in virtual reality. So the rubric scores calculate, for here, this rubric score is calculated by really taking the sum of these scores of all criteria and then dividing by the possible score, which for this example would be 6. And then the percentage scores are classified as low, medium, or high for this particular example. And so we can see here, like, for example, let's say that a player scored a 1 on each of the rubric criteria. So they earned 3 points in total. See, 1, 2, 3. We would say that they received a score of 0.5, which is 3 divided by 6. And that would technically fall in the medium range. And you can see here in the evidence model, observed score classified as medium, and then how that influenced the posterior probabilities that are now in the competency model. So you can see the prior probabilities started at 10 originally, right, before the prior probabilities. So this before any evidence was entered into the system, 10, 30, and 60 respectively. But now with this new evidence, the model becomes more robust and produces more accurate prediction of a person's overall tennis skill. So it's really the premise of how the evidence model connects to the competency model in really feeding the model with evidence to assess the probabilities. In lieu of time, I'm going to skip over this next example. So this here you can see is an excerpt of the evidence model for the HVAC recovery service. And you can see the competency model sort of here on the left-hand side. The observable indicators are listed here in yellow, and really it's only for it would have been a little bit too robust to show you the entire one. So we only see here evidence from the manifold, the most observable variables for the manifold gauge to AC hookup. And then on the right, we have this sort of back-end logic diagram for this portion of the virtual reality experience. So the 5 observables here are represented with the black headers. And the green boxes below them are the observable events that are triggered when a learner interacts with the virtual reality task. So these observable events are connected to what we have encoded into the virtual reality system as our hint system, which we use to really base our evidence rules off of. So this is the rubric that we used for the evidence rules. So the less hints a learner triggers as they complete the action, the more points they earned. So if a learner needed 0 hints, they scored a 5 out of 5 on the rubric. If they needed 1 hint, they scored a 4 out of 5, 2 hints, 3 out of 5, and so on and so forth. And the score was then categorized into high, medium, and low performance. Unfortunately, I'm unable to show you the Bayes nets for these, but essentially the statistical model takes in the information and predicts the proficiency levels of the higher order competency facets, similar to what we saw in the tennis example. So back to our thought experiment. So here's a social inclusion evidence model that was really just a quick analysis of factors of the social inclusion instrumentation literature, but really for this thought experiment wanted to give us something here to work with. So let's pretend that this has been fully validated and vetted with subject matter experts. So this is what we would use going into both our task model and our evidence model, and we'll talk about the task model very shortly. So how this would work is that the observable indicators on the very right-hand side, these are things that the system is looking for in the virtual reality experience, can now be scored on a rubric that evaluates, this particular rubric will be based on the frequency of demonstration out of total possible opportunities to demonstrate. So for example, let's take at the very top, there's a indicator that says ostracizes others from a conversation. So perhaps a learner is in a virtual reality scenario where they are having a conversation with two other virtual humans. And let's say that there's a fourth person in the room and the two other virtual humans aren't speaking to this person. And then let's say that you as the learner, you have 5 chances within the conversation to invite that fourth person into the conversation. However, you ignore this person 4 times before finally asking the person a question. Now, what we can do is we could score in our scoring system the frequency of observed ostracism as 4 out of 5, right? You ostracized someone from the conversation 4 times when you had 5 chances, and categorize this as high ostracism. Now, this high rating can inform the loneliness and isolation probabilities, as well as the social isolation probabilities. Now, that social isolation probability would then be inversely related to social inclusion. We will see how this plays out shortly. And then finally, the task model. So the task model deals with where and how we collect evidence based on learners' actions in the VR learning experience. So task modeling helps to expedite the design of various learning activities by really defining the specifications for the tasks, which essentially provides a blueprint for learning activity design. So task modeling provides guardrails for strategically designing tasks that solicit empirical evidence of the target competency facets within the competency model, right? So these are really, this practice helps to ensure that your learning design that you're creating for virtual reality is targeting the right behaviors to produce quality performance data to then feed into your competency model. So again, this maps back to your competency model and the evidence model. So what does it look like to demonstrate these competency facets that you want to measure in virtual reality? So the task depicted here in our HVAC example is to connect the manifold gauge, which is this red and blue thing here on the right-hand side, to the AC unit. And you can see an image here of where the hoses connect to the AC ports, the image below with the red and blue. Now, this task involves several interactions that the system can observe. So in the diagram, again, you can see the black headers represent the observable indicators that are connected to our competency model. And then the green boxes, again, are the observable events that our system sort of looks out for, like in the log data, those triggers for the indicators. For example, hanging a manifold gauge on the AC unit or tightening a fitting are things that those actions by the learner in the VR system are actually like event triggers that our system can then log to be scored, to be able to score that performance and evaluate it as evidence. Now, performance on these triggers are, again, scored using that rubric that we saw, which is based off of how many hints are triggered before a learner can do it correctly. Now, these events are automatically scored on our back end and then output our performance rating. I'm hoping that this plays. I'm not sure that it will, but let's take a look at an example of virtual reality task for our social inclusion thought experiment. So again, if you remember the scenario that I outlined, you're in a room with four people, including yourself. 2 people are ignoring the third person, and you have 4 opportunities to invite that person into your conversation. It doesn't seem like there's sound, unfortunately, but that's okay because I can share with you sort of what is happening. So these 2 folks right here are looking at you and are trying to engage in a conversation between the 2 of them and yourself. But you also have this opportunity to invite this guy who no one is talking to into the conversation. Now you can choose to speak to either one of these 3 people, or you can invite Mark into the conversation and say, nice to meet you folks. Couldn't be more excited to be working with you. What's your name? And direct that specifically to Mark to invite him into the conversation. So this is a conversation type virtual reality task meant to provide an opportunity to solicit behaviors associated with, again, social group involvement. So selecting that middle response, which is an observation of inviting another person in to join a conversation and an indicator of engaging in a conversation with those around you. So we can construct tasks, in this task model, we can construct tasks that provide opportunities for learners to exhibit the competencies, again, that we want to measure. In this example, only 1 out of the 3 response options involved the learner inviting Mark into the conversation. So by observing the learner select that particular response over the other 2, we can say something about their probable social group involvement. All right, just to sort of recap, because I know we're running out of time. Again, evidence-centered design for assessment is a framework for embedding assessments into the VR experience without disrupting flow, and can be used as both a diagnostic framework and a design framework. It's comprised of 3 models: the competency model, the evidence model, and the task model. Competency model operationalizes competencies into and observable facets and their relationships. The evidence model really scores all of the evidence that is collected from the task model, which aims to solicit those particular behaviors from the learners. So your mission, if you choose to accept it, I would say try it out. Even if you have no intention of building and fully developing out an experience in virtual reality, applying evidence-centered design to your next learning experience design project can really help bring into focus what needs to be learned and how it can be evaluated. It's a really great framework for that. And it provides a great approach for a very focused and intentional design ideation session. I have a number of references here and resources Super helpful articles. If I were to suggest, two, I would say look up any of the research by Dr. Valerie Shute out of Florida State, and take a look at the Miss Levy brief introduction to evidence-centered design. It's amazing. If you want to learn more about evidence-centered design, I would say start there. And thank you so much for attending my session. I know we ran into some technical issues. I apologize, but I hope I've made you as excited about ECD as I am. And if you have any questions, feel free to reach out to me on my email. I'm also available on LinkedIn or Twitter. Just wanted to thank you all for attending this session.
Thank you very much, Christine, for your interesting talk. I hope you can hear me.
I can, yes. Thank you for having me.
I'm your emergency session chair.
Oh, hello. Nice to meet you.
Nice to meet you. We have two guys here in the session. Maybe, do you have some questions for her? Oh, maybe. Do you have some questions for Christine?
My only question is how are you working with the bias on if a person works with VR, how you take the significance in if that the person does not understand how this technology works. Like if I give an 80-plus-year-old and his Oculus or something like this, how can we take this in the condition that the person doesn't realize on the right side there is a person, because the technology is new for this person. Sorry, I cannot explain it better because my English in this technological frame is quite limited. But do you understand my question?
I do. Okay, and yeah, no worries. I think that comes down to sound design practices, right? We definitely, and that screen share probably wasn't the best because they were out of frame, but in a 360-degree environment, we would really hope that where you're situating the learners is somewhere completely visible, so that, if they're behind them, no one expects you to have to turn around, and you might assume that that person is not trying to be part of this conversation. So it's definitely something that we have to take into consideration when it comes to designing the space, but also saying, is that even valid evidence, right? Is it even valid given the context of the virtual space and the situation happening in that space? Is it valid to think that the learner believes that that person should be part of this conversation, or is it valid to say that they aren't? And I think for us, it really comes down to before publishing a VR experience, doing a lot of play testing and really learning from learners. That is something that we can definitely control for when we're sort of going through play tests, learning from learners about whether they believe that that person should have been in that conversation or not. So I think, definitely something we can mediate with additional research before even getting to the point where we're saying your action on including or excluding someone is actual evidence, right? So there's some validation that needs to happen beforehand for sure. But thank you. That's an excellent question.
Thank you. There's another question in the chat. How do you differentiate between formative and summative assessment? When is this the evidence showing learning versus mastery?
Mm-hmm. That's a really great question. So far, we have been primarily focused on formative assessment and measuring learning. For these virtual reality experiences, we like to emphasize replayability and being able to track your performance over time with space practice. So we haven't quite gotten to the summative portion in like, when is that, when does it qualify as you have mastered these skills? So unfortunately, I'm unable to share with you any details that we've been working on, but we do emphasize that in the scoring scheme that we currently have today, really focused on formative assessment and replayability of these virtual reality scenarios. And that's not to say at some point, you know, based on how these virtual reality trainings are implemented or how people are choosing to implement them and whether they want performance metrics at certain points in time. Yeah, I think it really depends at case-by-case basis on what the manager or the admin is saying as we need scores by a certain point in time. But I could just share that with our current focus, we haven't really been looking at summative assessment.
So thank you very much. I think we are running out of time. So thank you very much again for your interesting talk.